streaming here. Okay, so I think it's working, and I'm going to wait for the delay to confirm. Oh, yeah. All right. So, by the way, this is episode 9 of my stream series called Kyle and Friends. And you are, this is Ryan Olson. And this is the first person that, not that I knew in real life before the internet, but the first person that I knew in real life before the internet that I actually worked with in graduate school. So I've never talked to somebody on the internet, on YouTube, that I met before whatever. So, Ryan, thanks for coming onto the channel. And would you like to give a short background of yourself?
Yeah, sure. Thanks, Cal. Thanks for having me. I appreciate it. So, like Cal mentioned, we went to grad school together, worked together. My PhD was in nutritional sciences, which is shocking to Kyle. But
Thought it was
so we were in
exercise
the same
science.
program. Yes, exactly. I think we started off maybe, were we off a couple years, maybe 2 years apart from one
I think you were
another?
2 years ahead of me.
Yeah. So that's probably part of it. But we worked together as teaching assistants for a physiology lab, and that's kind of where we met, and that's where I learned about Kyle. And a thing I remember most was, I believe, for a while you were doing some martial arts. Are you still doing that, Kyle?
Yeah, because we talked about that because you had the Muay Thai person on your
Yeah.
like endurance tests and stuff. So yeah, I was doing Muay Thai and Brazilian Jiu Jitsu up until the last week in January when I suffered a pretty catastrophic injury. I had a pec tear,
Oh no.
and then it was surgically repaired about a month, so like the end of February. So I'm just now kind of supposedly back to normal. But it's actually driving me crazy because it's one of those injuries that you don't ever know if it's reattached the same way as it was before. Like they just can't
Yeah.
even tell. Like there's no MRI and there's no scan to know. So like you never know. If you like, not that I lift heavy or anything, but if I wanted to like bench press a lot of weight for the rest of my life, in the back of my head I'll be like,
Yeah.
who knows what'll
Very
who
concerned.
knows what'll happen on my right side? It could just like rip off like a chicken. But yeah, I still do that. Yeah.
That's very, not to get off topic here, that is a very specific injury. And my first year as a PhD student, my advisor suffered the same exact injury, bench pressing, working out. And during a conference, I used to have to change his gauze pads because we were rooming together and he was just post surgery. And I drove him up to Vermont for a conference because we had a presentation up there and it was my first one. I didn't know what I was doing. And I remember vividly having to like pull his bandages down and put the ointment on and put him back on. Ooh, it was a nasty injury and a nasty surgery he went through. So hopefully you're feeling a little bit better. I know that's not a good one. He still says, so you're kind of right. He still says he's got some weird range of motion stuff and some weird scar tissue buildup, and it just feels a little bit odd sometimes, especially if he does like single arm type of workouts, like isolating just one side versus doing like a bench press. At least it's a little distributed better.
Yeah.
Whereas the single stuff, he said he feels very nervous, especially with dumbbells.
Yeah, it's also what. So for me, I think it was a full tear of one of the two heads. So my muscle
Yep.
was still attached by one, so it like wasn't, I guess, as bad as it could have been. But the motion, it never actually felt like it affected the pressing that much. But I drive a manual transmission car, and the night it happened,
Oh,
I
yeah.
went to try to drive home, and I had to shift with cross over my body with my left hand because I reverse for my car. It's a Mini Cooper. It's all the way to the left, like an extra click, and then up.
Okay.
In some cars, it's all the way to the right. Um,
Uh-huh.
and the second click is more force, because like just to the left and up is first, and then it's like that, and then another one, and you have to like it's like a chest fly kind of motion, like abducting. I couldn't do
Yeah.
it. It was like that motion was deleted from my toolbox of movement, and I that was extremely it's just bizarre and weird feeling that, because it didn't hurt that bad, the injury. Like it hurt, but it
Yeah.
wasn't. I'm sure a broken bone hurts a lot more, but it was just
Yeah.
like a one of my force direction abilities was just deleted from.
Oh man, that's so bizarre. Yeah, you don't realize how important it is until you need it.
Yeah.
Yeah.
So okay, so we went to graduate school at least for a decent amount of time together, and you are now
Mhm.
in Texas. What's the school again?
Yes, I'm at University of North Texas, so I'm in my, I guess this is starting my fifth, sixth year.
Wow.
I forget. I started in 2016. Yeah, so it's been, last year was kind of a blur, so I don't even count last year. But so I guess my fifth full year here. And I'm up in a little bit north of Dallas, about 30 minutes north in a town called Denton, Texas. They call it Mini Austin. Our school is more known for our arts program, our music program. We have a lot of Grammy winners here. We have a lot of professional dancers that come out of our school. It is Texas, so sports do rule. They are really trying to build up our sports programs around here, especially football. Um, so yeah, it's a good, I would say, decent sized school. We have over 40,000 students in total, so it's big in terms of like student enrollment, but in terms of like the research and things like that, it's not maybe quite as like up to snuff with
Mm-hmm.
Rutgers. We were recently just given the new classification of the highest tier of research activity. That happened in 2015, so the year before I got hired. And then part of my hiring was because they were bringing in people who came from big programs who understood the hierarchy and the structure of the high research activity, what it meant to actually be a part of those programs. So it's starting to pay off. We've moved up pretty quickly in the rankings in terms of our research within the last 5 years. So I don't know what last year is going to do to everything. I think that probably messed up everyone for the most part.
Yeah.
Uh, but
You can use it
but
as an
they're going to
excuse
continue to
though.
push the research. Well,
When
I
you're at a
most
tenure.
most fac well, most faculty, we were they do it. They called stop the clock
Mhm.
basically. Pretty much every faculty was required to take that last year, just because it was just such a, some people could have gone crazy with their research and others maybe didn't do anything. Depending on your work, like I do human subjects work and I can do
Yeah.
anything. Whereas someone who's maybe studying more research survey type questionnaire, maybe they thrived during this time period. So they just had pretty much all the university go on a stop the clock. So it's like last year didn't happen.
Yeah, that I would like one of those too, because when I had to stop going to the lab last year, it was right after I had finished a manuscript. It was the worst timing possible. Like if that had just been juxtaposed, 3 months differently, then I could have, stayed home for that amount of time and just worked on that manuscript and then, planned something new. But
Sure.
it was pretty bad, pretty brutal.
Great. Now what do I do?
So okay, so in graduate school, you were in my department, but similar to me because I was in nutritional science, but I was working in a lab in endocrinology. Was your lab, the PI of your lab, was that in the primarily in the exercise science department,
Yeah, they have
like a dual
they've
appointment or
changed names
something?
now. Yeah, he had a cross appointment or dual appointment with nutritional science. He was a grad faculty, so he could only take grad students from that program. And the main reason is because the exercise science program at that time did not have a PhD program. They only had a master's
Oh, that's
program.
right. They were trying to get new
And
people.
yeah, but now they do have a PhD program. That happened the year I left, I think, is that they finally had one established. So he's no longer pulling students through nutritional sciences. He has his own program he can pull them through. But that's how I got here. So I had worked with him as an undergrad at University of Wyoming. That's where he originally, actually, he got his undergrad there. He used to wrestle. He was a D1 wrestler.
Nice.
And he wrestled there, got his degree there, went to Arizona State, got his PhD, kind of bumped around to a few universities, one of those being University of Wyoming. And I worked in his lab as an undergrad student. I was, I think, a junior, and he was looking for volunteers. And I was like, I liked the topics he was discussing. It was more of an exercise psychology type of topics, like why people choose not to exercise basically when we know it's one of the healthiest things we can do. Kind of answering those questions, talking about motivation, what actually motivates people, how do we get people to be more active? So those kind of basic questions. Um, so he was doing some research. I volunteered. I researched for him for 2 years, and then he left. And when he left, I knew he had gone to Rutgers, but I kind of lost contact, and I was going to go to be a physical therapist. That was my original
Mm.
goal, was to get into physical therapy school. And I just kind of lost motivation for it. I did all my observation hours. I did, outpatient, inpatient, private clinics.
Oh.
I just hated it. Like I could not bring myself to do that the rest of my life. And no offense to people who like that, but I just was not happy doing any of that work. It didn't really push me, mentally. I just felt like an industrial job. I was doing the same thing over and over and over again. I said I would never do that. So I called him up and said, "Hey, I know you're at Rutgers. Are you looking for a grad student of any sort?" And he's like, "Actually, we have a line that we have a PhD line." And I applied way late. Applied in July, prior to the program starting in
Right.
August. So it was a very expedited process. I got accepted, kind of moved out there with my at that time girlfriend. We're married now, so
Nice.
but at that time we were dating, and we kind of packed up our cars and just drove what we had in our cars there. We didn't have a place to live or anything, so we stayed with my advisor for a few weeks, before school got started, and we found an apartment finally, and then that's kind of how I ended up in that program. And yeah, like you said, I was a little bit, how you were more like biology, endocrinology. I was in a totally different building than the rest of the nutrition students. It was all the way across the field. How am I ever going to go see those nutrition
Right.
kids? But I was in a separate building down in a basement, and I was the only student, really, the only graduate student. And then we had about 10 undergrad honor students that would work in the
Mm.
lab. So I was in charge of that for 4 years by myself. I didn't have another PhD student. So that was a lot to manage. So the whole like mingling and going to learn more about, like, I just didn't have time really to go and do that stuff. But yeah, so that's kind of my background. And then yeah, most of my research was heavily involved in kind of sport and exercise. I'd say psychology, but really it's psychophysiology, because we were looking really at things like cardiovascular responses through heart rate variability. And we were also looking at a lot of brain activity, brain related activity through the event related brain potential technique. So that's done through an EEG assessment. So we're, implementing certain paradigms. We would have people exercise, or we would look at their fitness and see how that would maybe correlate with their brain activity responses. And that was kind of most of the work that I was doing at that time.
Okay. So I remember, like I said about the Muay Thai guy, that you said there was the one person. Was he the only person that sort of, you said he sort of like easily maxed out all of the equipment and he was super duper fit?
Well, no, he's not the only person. I mean, we had some world class athletes
Okay.
come in and do stuff. I mean, it's really neat to see those things and to see their different backgrounds and like the various activities you can do and still, max out various things. I remember we had an ultra marathoner come in, and I just had never seen anyone run that fast for that long. I just, my mind was totally blown. But at that time, we were doing a lot of aerobic capacity testing or cardiorespiratory testing, where we're looking at VO2 max, and just, you can classify people on their fitness levels based on measuring indirectly or through indirect calorimetry, measuring their basically CO2 output. And it is heavily regulated by your genes. That's the only thing. So you could have someone who's in crazy shape, but genetically their fitness levels are not that high. It's just the ceiling is set a lot by genetics. So you can push that a little bit, but you can't really, if both your parents were long distance runners, the likelihood of you having a higher VO2 max naturally is much higher than someone
Right.
like me. Neither of my parents were active. So I'm just less likely to have that high of fitness. Even if I train really, really hard, I probably would never get to a level of someone with parents that both were ultra marathon runners.
Yeah, that's one of the things that I noticed watching MMA is there's some fighters that are, famous for having a lot of endurance, and people will say like, oh, this fighter doesn't train cardio. But I don't. When you've done the sport and you've seen people, you can just see there's some people that have that more explosive type energy, and they just can't sustain that for as long. And there's some people that kind of hit a gear, and it's different for different people, and they can just sort of stay in that gear for it seems like basically forever, like just and yeah, it doesn't really, from my observation as well, like watching professionals and then like in the gym seeing people, it really seems like you kind of have a certain style, kind of like how you have a certain body type. You have a certain
Hmm.
style, the way your endurance and the way your power output works, and you can improve it, but you can't really change your type, or at least
Yeah,
we haven't figured that out.
well, there are certain muscle fiber types and things that maybe make you more inclined to do certain activities, and usually people do things that they're more successful at, right?
Right.
Or things that they enjoy more. And so running, for example, could be a miserable experience for someone who's got a lot of, of that power producing muscle mass or muscle tissue. And so they might be more inclined to do the heavy weight lifting because they see impacts more. Whereas other people who struggle with weightlifting or putting on weight might feel more inclined to run and do long distance type stuff, cycling, because they realize, wow, I can really do this quite efficiently, not a lot of stress on the body, and I feel really good afterwards. So I think there's a combination of kind of what you're born with, but then also, you know, how well you perform those actions, that's really going to feed into you continuing doing it over and over and over again.
Yeah, yeah. All the people you see professionally, like they, their story is that they loved doing it as a kid, but if they didn't have the predisposition to being good, they'd never make it to the level where you're seeing them, like at the
Yeah,
Olympics or something.
yeah, exactly.
So I also remember you had, and before we went live, you were talking about the meditation stuff and how you're not
Hmm.
doing that so much anymore. Where did that fit into the exercise stuff?
Yes. So, part of being the only PhD student in a lab is you do every project.
Right.
You coordinate every project. And my advisor at the time I'm not going to call him a generalist, but he was kind of dabbling in multiple areas. And a lot of it was based on, whatever stuff you'd read or new theories in our field. And he was really trying to look at exercise as being, you know, as not being all and be all in terms of health. And so he wanted to see what if you add exercise to certain other paradigms. And so we connected with a professor at Rutgers. Her name's Dr. Tracy Shores. She was one of the first people to look at and examine neurogenesis in the hippocampus of mice and how stress impacts that growth of those new cells. So we know that the new neurons in the brain are only generated in like two areas, the olfactory bulb, which, whatever. And really the big one is the hippocampus, because that's really related to like that long-term associative memory. And so that was, her field. And she's still, I believe out, yeah, she's still at Rutgers now. She's a distinguished professor, but she's kind of nearing the end of her career and is really looking to translate her animal work into human work. And so there was a big push for grant submissions when I was there, obviously, right? And so we were trying to get a lot of pilot data built up for some grant submissions looking at human neurogenesis. And what she found through her animal research was that the most effective way to not only increase the number of neurons, but then retain them to where they're mature and they stay in the hippocampus is through a learning paradigm. So she found out through exercise experiments that exercise increases the number of new neurons in that hippocampus, but many of them die because they don't fully get integrated and they don't mature. Now, in order to retain those cells, you then would have to engage them through some type of learning activity. And that showed a massive increase. I can't remember the numbers and I don't want to misspeak, but I think threefold, fourfold increase in the number of cells that were actually retained following both the exercise and the learning paradigm. So we had a paradigm, right? We had a translational model, and we're just like, how do we then move this over into humans? And we fished for the learning paradigm forever. We're like, well, what if we teach them a new language? What if we teach, and we're just like trying to think of like ideas. And one of them, I remember it was like, what if we teach them how to juggle? I was like, well, okay, but there's a physical component to that. And then we were looking at exercise that had a learning component to it. which I didn't really like that because you can't decouple those two things,
Right.
right?
Like a
If you're doing them at
sport,
the
like
same time.
something that's a skill.
Yeah, yeah, exactly. And so we wanted two very just crisp learning paradigm exercise. And
So
then
you
we
could
have
have
our
a
four.
group that just does the exercise and a group that does
Yep,
both. Okay.
exactly. Control group, exercise group, the learning group, and then a combined group, right? And then there's a lot of different questions we had to ask, like dose. If you have someone exercise for an hour, someone does a learning paradigm for an hour, do you do the combined group? Is it an hour total or is it an hour each? Or is it, so you have all these little like things and there's so much you have to like write it
Because
down.
the
It's a,
one group would get 2 hours of stuff.
that, yeah, then you're getting double. And it's like, okay, well then now that doesn't, but then they get half the dose of the exercise in the learning paradigm. You're like, if you do it the other way, it's
Right.
an hour total, but it's half of each. And I'm just like, all right, this is not fun to think of. We could probably do a dose study just by itself, right?
Yeah.
Kind of proof of concept efficacy type thing. So anyways, we thought forever, ever. Well, we started dabbling with like the whole meditation stuff and how, it is very anecdotal in the sense that if you talk to people who meditate, like we had Zen monks, for example, that we met with and consulted with. There's actually a Zen
Nice.
monk thing at Rutgers. I don't know if you knew that, but they had a little area where they held on Cook campus. They held their sessions 3 times a week. I think Monday, Wednesday, Friday for students for free. So it was a meditation thing
I
that
don't
they
think
would do.
I don't think I knew that. Darn.
Yeah, well, they didn't advertise. Well, I'll tell you that because it wander upon it when I was at the gym one day and I was like, oh, what's this? It was like a little cutout. I was like, this looks shady. I'm gonna go. So I'm gonna try this out. So we met with them and they talked to us about how meditation, especially serious meditators, they're always learning about themselves, and it's a very complex thing to tell someone to stop and just like breathe and focus on one or two things, and
Mhm.
you're still going to think and have alternative thoughts, but then it's like, how do you get those thoughts to not impact your behaviors? How do you live more in the moment and stuff like that? So we ended up, there were several collaborators on this project, and the vote ended up finally going to where, yes, let's do meditation because otherwise we're never going to do anything.
Mhm.
So it was kind of like I don't know if it's the best learning paradigm, but I think it was a good learning paradigm, and I'm glad we did it because there are other properties of meditation that are also going to be beneficial. And I should mention too, most of this work was done in a college age group, but all of them were diagnosed with major depressive disorder. So there
Oh.
was an additional caveat with our groups. So we had a healthy, right, a non-depressed group, and we had a depressed group. So, but we also were looking for, if you're giving someone treatment, it's kind of an ethical dilemma, right? Like we know exercise has been beneficial. We know meditation is beneficial. We do not know that juggling is beneficial, right? And so we had this kind of conundrum of like, well, we need to be providing them some type of treatment
Mhm.
option. Has been shown in the past to have a little bit of efficacy. Otherwise, it's not good to have people in a meditate or in a trial where they have depression. They think they're going to maybe get some treatment, and you just have
Teach
air
them
juggling
juggling.
now. So that was part of it as well. So we did our training. The monks trained us, which was really neat. We had several one-on-one sessions where they just taught us how to, um, basically how to teach without any type of connections to spirit or religion or anything, just straight on run of the mill, focused attention, breathing meditation. Just very basic form of meditation, which is the most basic form you'll see through apps and everything
Mhm.
else. Um, so yeah, so we integrated that and we called it MAP, mental and physical. So it's called MAP training. There's actually a couple websites. I think we're on the news at one point. I don't even remember now, but mental and physical training. And we had our cohorts, and I would coordinate these programs. They would meet at the gym. This was all group setting too, because then you get into a dilemma of social interaction.
Mhm.
If you do one-on-one, if you're not doing group training versus individual training, that's a whole different can of worms right there. So there's a lot of variables that were hard to control, but we were doing mainly efficacy stuff at that point. It wasn't like a full blown, fully scaled out randomized controlled trial. It was a controlled trial, randomized, but it wasn't to the power and to the numbers that we probably needed. I think we finished with like that project took like 4 years, 3 years. And that was, I think we finished like 150, maybe like that, something like that.
In total?
Um, in total. Yeah. So it was, I think, yeah. So I think it was, or maybe 140, because I think it was 70 non-diagnosed and then 70 diagnosed, because we also had the comparison groups.
Right.
So it was it was a really neat project. I ran a lot of meditation sessions. One thing they don't tell you, kind of like exercise, how you can get burned out if you exercise too much. You can meditate too much. You can. I was holding sessions 5 days a week and often on weekends and multiple times throughout the day. And so I would consistently be driving over to Bush campus, back over to Cook Douglas campus, back and forth all day to run sessions. And it was just like a nonstop thing. So it's probably a good thing I was meditating so much. Otherwise, I might have maybe lost my cool. But I got very over meditated by the end of those programs, because they were all 12-week programs.
Over
And then
meditation.
we'd have a little break. Yeah. Then we'd have a break, and then we'd recruit for our next cohort. And that's kind of how the process went. So it was a neat project, because it makes you learn a lot about your own resilience, and like it really pushes the boundaries of how far can you push yourself and how far can you go both physically and mentally to make sure these things get done. So it was like a twofold learning event for me. It was cool research. It's all published at this point, and then it was also just like for me, it was really nice to work with more of a clinical population and then look at how some of these things affect those
Did
individuals.
they seem to like it, the people that were doing it?
Yeah, so we always, quality assurance type stuff, right? Right, quality checks. We did some pilot testing before we ran the full trials. We got some of the kinks worked out, some of the logistics. Most everyone enjoyed it. A lot of them did not like the meditation, especially to begin with.
Mm.
It's a super hard thing to learn, and 12 weeks is, dare I say, maybe not enough time to really get like an understanding of it. I would say a lot of them really found their groove near the end of the programs, and so some of the complaints were they wished it was longer, which I totally get. I wish we could have gone a little bit longer with those programs, but it's not to say they couldn't do it on their own, right? That was kind of the hope. And we didn't do any follow-up testing at that time, because we weren't doing, well, we didn't have the funds, but we also just weren't doing the follow-up. So it was never in our study design, because that was what the grant was for. We wanted to be able to write a really elaborate,
Hmm.
grant and pay for follow-ups. Um, so yeah, it was. They all seemed to really enjoy it. Both groups had benefits, which was also very interesting. The healthy group, non-diagnosed group, and the diagnosed groups both had massive benefits. We measured obviously depressive symptoms. We measured anxiety symptoms. We measured rumination was a big one, as kind of one of our big outcome variables, negative ruminations. And then we also, we it's really hard in 12 weeks to have a clinical diagnosis and then to say that they are no longer
Right.
clinically diagnosed, right? So our main endpoints were those symptoms, because symptom treatment, you would hope that over time, if you were able to reduce symptoms enough, that eventually that will lead to a change in your
Hmm.
diagnosis. But so it's really hard to make that jump and leap and say like they were no longer depressed. So we focused more on those symptoms. And like I said, every single group, I should have brought some of my figures, dang it. But it was really neat, because at that time, being the only student, I was also having to learn how to new like graphing techniques and ways to
Hmm.
show individual data better instead of just showing a bar chart. I don't know if you've heard of this before. It's called bar plots. It's this group who they don't want to use bar plots to show individual data, but basically because you wash out individual effects, right?
Right.
And so it's a really neat image where there's a line that represents the average
Hmm.
change, but then you have individual circles that show individual changes. And so you could look at individual basis, these massive decreases or increases. And it really helps with outliers too. So you don't have someone who scored a 98 on the scale and then all of a sudden they're at a 2. That's going to have a massive effect on your average. So it really allows you to go and look at those individual data points. So you could just tell from the data that the showing the return of those symptoms in the depressed group to more, non-depressed levels was great. They almost matched, their change was much greater than the healthy group, but their change was so low that it almost went down to where that healthy group was, which was really cool. So that was the first part of the data, which was really neat. But I think the coolest part, and this is just because I think it's better than maybe some of just the questionnaire type of stuff because it can be semi-subjective in certain situations, was the brain activity data. We actually had some neural data showing that the depressed group, especially at baseline, had a deficit in their inhibitory responses. So when we talk about inhibition or inhibitory control, oftentimes that's an inability to stop doing something.
Mm-hmm.
And so that's why we're so focused on rumination, right? When you ruminate, you can't stop thinking about things. Whether it's good or bad, doesn't matter. It's just you can't stop the process. And that's a hallmark symptom of depression. And so we found that with changes in rumination, we saw these changes in brain activity that returned more to, I guess you'd say, like normal-ish brain activity, which was the coolest thing to see a waveform actually change from baseline 12 weeks post. You see this waveform return back to a normal level and you go, whoa. So there's actually something
Nice.
probably physiologically, biologically that's going on that we can't answer through our techniques. But again, that's, we want to have that foundation for someone else to study like what's actually happening. They also did some fMRI recordings in these groups. I don't know if anything ever happened with that. They said that there were some structural, changes, structural and functional changes in the dorsolateral prefrontal cortex, the anterior cingulate cortex. I don't know if they were, I don't know what they're using that data for at that time. I was not heavily involved in that portion of it. I just kind of, I haven't read anything on it either, so I don't really know what they found with that data. But I was very pleased with what we had.
Yeah, is that like when you were doing this project, were there other people doing similar stuff in the literature, or is it kind of a one-off like weird project?
No, there was a lot of research in the kinesiology world of looking at the effects of exercise for treating depression. Like there's a massive literature
Well,
base
yeah,
for
yeah,
that.
yeah. But with the
Yeah, and
meditation.
there's also a massive literature base for meditation and depression,
Mm-hmm.
right? It's just no one had really looked at the synergy between them or potential synergy between those two, combining them and looking at them. So as you can probably expect, the outcome, the combined group did show the greatest effects, just marginally. It wasn't like anything to write home about. Every group showed substantial changes,
Mm-hmm.
which was great. Or significant changes from baseline. So that was cool. That was just right there was a good thing to see. But the combined group did show the greatest benefits, I suppose you'd say. Now, I would really, obviously, if I were to do it again, there's a lot of things I would do differently. I really want to do follow-up testing. I really want to maybe push the meditation and exercise up a little higher. I don't necessarily think the dose was enough. I don't think the intensity was enough. There's certain things I would love to change to look at more of that. If you really want to see some changes, you really got to kind of push people out
Right.
of their comfort zone
How
a
long
little
was
bit. So
the
that's
meditation session for?
so it was kind of a ramped up protocol, same with exercise, because most of the people coming in were what you'd classify as sedentary.
Mm-hmm.
That was one of our one of our inclusion criteria was sedentary. So we'd have them fill the questionnaire for the activity levels and determine their classification, and then we also ran fitness tests on them to confirm that they were of a low fitness level. So they did have a lot to gain. So that is another kind of potential limitation, right? But we did ramped up protocols. So we would start. Let's see if I can remember this. Even before the program started, like 2 weeks prior, we gave them some lead-in information on what to expect and what they'll be doing. We had some one-on-one sessions where we kind of familiarized them with the sitting technique and the breathing techniques and things we're going to talk about. And then on day one, we did like right off the bat, we did I think we were doing 15-minute, and then so that was week one. Week two, it was 20-minute. Week three, we moved up 25, and then week four, it was 30, and then we sustained 30 3 times a week for the entire 12 weeks.
Okay, that seems
Yeah, but it
reasonable.
was always 3 times. It's a lot. It's actually kind of the meditation component is just when you start talking about meditation, 90 minutes of meditation a week is actually a decent amount, whereas 90 minutes of exercise is not
Right.
that much. So we had to find a balance between them where minute wise we could somehow, compare the two.
Right.
it's just, they're hard to compare. They're just, mechanisms are so much different, right? So yeah.
All right. And so, and that was kind of, that got published, and then that sort of the end of that. Is anybody following that up back at your grad lab, or not really?
Um, I don't honestly, I don't think so. I think they moved more towards, so it was heavily based on grant funding,
Mm-hmm.
right? And once that funding ran out, it was kind of like, what's next? And they moved more towards, and I've moved more towards really narrowing down the neural activity and neural changes following just exercise interventions at various intensities. Like, there are so many questions in kinesiology, especially related to the dose issue of how many days per week, what type of activity, right? Like hiking versus biking versus walking on a trail. Like, there's so many different types of activity. Okay.
Mm-hmm.
So we don't know any answers to that. We don't know how many days per week people should really be exercising for mental health benefits. We don't know the amount of time. Is there a minimum amount of time? Is there, is there a maximum amount of time? And then the intensity is also another issue. Some people really like high intensity interval training,
Mm-hmm.
and that's been shown to help reduce anxiety, but has not been shown to be that effective for depression. Um, whereas long, slow walks has not been shown to be overly effective for anxiety, but has been shown to be pretty effective for depression. So, like the intensity issues, the comorbidity issues, if you're talking about depression, anxiety, like there's just so many simple questions in the field of kinesiology that haven't been answered that, you make a career out of that, let alone integrating some other intervention, which I would like to do someday. Um, I would like to tap more into my nutritional roots and maybe bring in some nutritional interventions. I've done a little bit of collaboration here at UNT where I do some nutritional type of interventions for performance, and I look at brain activity kind
Mm-hmm.
of pre-post to see if there's effects. But there's no like specific hypotheses usually when we're doing that stuff. A lot of it is kind of, it's not I would say it's not maybe the cleanest
Right.
in terms of like the designs and what I would want to do. I was more brought up in like the clinical randomized control trial type of mindset where like everything has to be controlled for, all hypothesis driven. And when you get kind of into the, especially applied world, a lot of that
Right.
stuff people don't think about as much. They're more interested in external validity, right? They want like, yeah, but could I actually do it?
Right.
Just like, maybe, but we need to establish the bench science first, before we move on to just applying things.
What what do you use to measure the brainwave activity?
So we're using, we have, you can use all different systems. There's various things you can do nowadays, but we use electroencephalography, so EEG electrodes. We only need a 32 channel system. We're not doing dense array EEG where we're not doing oscillatory activity, right? We're not looking at like alpha, beta, delta,
Mm-hmm.
gamma, any of that stuff. That is a whole different area, actually. If you start getting into that, it's very different from what I do. What I do is they're called event related brain potentials. They're derived from an EEG signal. Okay. So let's imagine I put these electrodes on your head. Boom. We got 32 electrodes. We have you kind of relax for 10 minutes, just kind of get used to wearing them, get kind of settled in, get the jitters out because people are usually a little bit nervous having this stuff on, asking weird questions like, are you putting electricity in my head? And like, no, I'm recording your electricity. It's really cool. So we do that for a while, and then they're called event related potentials for a reason, because we elicit an event. And so usually what I use cognitive paradigms. I create paradigms on a computer program. We sync them up with the brain activity. And for example, I think you can hear this, but a clap.
Mm-hmm.
Okay. So when you heard that clap, your brain made a secondary spike. Okay. Somewhere probably in your occipital region and somewhere near your hearing regions. So there was some activity that picked it up. Now, if I started to alter the tone, can you still hear that?
Mm-hmm. Mm-hmm.
Okay. Did you hear that one?
Right. Yeah.
Okay. And then that one's louder. So your body's going to pick up that louder one. You're going to have a bigger brain response to that. And so what you're doing is you're just, through cognitive manipulation, you're making more difficult trials versus easier trials. And then that cognitive experiment can measure certain aspects of cognition like attention, working memory, inhibition.
Does the
And so
subject
you can start to
see
think,
their own responses, or is that
so
just for you?
that's for us, but we show them, for example, if I move my head or do anything, grit my teeth, move my eyebrows, that screws up all the data. And so we tell them oftentimes to like, we put the screen up and it shows their waveforms across the screen. And I'm like, move your head. And they see the data go all crazy. I'm like, that's not good. I'm like, grit your teeth together. And you see the screen goes black because the muscle activity way outpowers the brain
Mm.
activity. I'm like, see, that's bad. And I said, so we'll tell you, I said, we'll tell you if we notice you doing anything like that, we'll, ask you to, to stop. And we have a video camera on them and they we'll warn them. We give them breaks. Obviously it's it's a small little sound acoustic room, like a recording room that they're in. And it's air temperature controlled. So if they need it hotter or colder, we can do that so they're comfortable. We do give them caffeine, which is funny because there's like a whole argument about do you give people caffeine when you're doing this stuff? And I say, absolutely. Have you ever sat down and done a cognitive test for an hour? You will fall asleep.
Right.
Like if you want people to really perform at their peak, if that's what you want them to be doing, then you will obviously give them whatever they need to be comfortable. So if you told me not to drink coffee, I'm an avid coffee drinker. If you told me I couldn't have coffee for that experiment, I would way underperform. I'd probably have a headache, right? I would suck. So we just make sure they're comfortable. So anyways, we do these experiments. We give them several hundred trials of each one because you need a high signal to noise
Mm-hmm.
ratio, right? And people are going to miss questions. So if you want to only look at how people respond to incorrect responses, you can do that, but you need a lot more trials, right? Or the experiment needs to be tougher. But we mainly focus on correct responses and how people respond. We're looking at reaction time, we're looking at accuracy. Those are basic metrics. But then we go and break down the signal. We actually process the signal in 1 second intervals, basically. And you can get it's really hard for me to visually describe this with my finger here, but basically there are various waveforms that go up and down. And each waveform represents a cognitive process. Okay, so there's sensory stuff that happens very early on and it's very small. And then there's bigger type of motor type of stuff that occurs later on, which is really what we're assessing. So we can look at the amplitude of those and we can look at how long it took for that to hit its amplitude. And those metrics give us a lot of information into like basically the number of resources required to complete that task. How many neural resources are you having to engage to then successfully complete those tasks? Are there distractors? So we'll throw distractor stuff in there. We'll maybe play music. We'll do things to maybe throw them off, and you can actually watch their waveforms start to sink down because their attention is divided, right? You only have a set number of attentional resources, and when you start to do multiple things like dual task paradigms, you start to see those resources get put elsewhere. So I really like the lab now because I customize all my stuff. So I have a custom bike that I built and it's got a screen mounted to it. And we have people exercise at very low intensity. They're back on a recumbent bike, kind of like cycling,
Mm-hmm.
and it keeps their head still and everything. And so we can actually have them exercise at various intensities and look at that impact live on brain activity to see. You can actually watch the attentional resources start to dip in live and kind of see them drifting and not focusing so much on the cognitive paradigm. And maybe they're more focused on their activity, right? Their muscle activity because they're having to engage their muscles. So that's some cool stuff. It's got cool implications, beyond just, think about like military settings, firefighters, like jobs like that, where you're highly active and making complex decisions. Brazilian jiu-jitsu, right? You're consistently
Right.
in a state of physical activity, right? But then you're also like, you're feeling out weight shifts and you're
Mm-hmm.
trying to decide what you're going to do next. You try not to consciously process, right? You want it to be just reactive, but
Yeah.
there is some processing that's going on. It's the same kind of idea there.
Yeah. Yeah. That's actually a good example because you can see people that when they start out, you can almost see physically in the way they move when they shift over from like more thinking to that kind of, I guess you would call it muscle memory, but just being able to offload more things like off of the cognitive, front and center, and to the point where if one person is really experienced, they could like be having a conversation because they don't need to use that many resources for what they're doing.
Yeah, exactly. Yeah. It's like, we, I always tell students, it's funny when I see people at the gym exercising at high intensities and they're like reading a magazine or studying. And I'm like, there's no way they retain any of that. There's absolutely no way because you can't, especially at higher intensities, your body is more focused on survival.
Mm-hmm.
and it is not going to retain the information or anything that you read or did during that time to a level where you could like remember it and it gets consolidated into long-term memory. Now, low intensity exercise, on the other hand, yeah, that, walking and low intensity
Mm-hmm.
jogging, absolutely, that stuff you can retain. But when you start getting those higher ends, I see those people, I'm like, nope, that's a waste of studying.
Yeah, I can
Just you might as well focus on your exercise at that point. You'll be more
I
efficient.
can feel that when like I listen to a lot of audiobooks, and I know a lot of people can't pay attention to audiobooks, but I'm pretty good at it. But then once in a while, I'll realize, like, say, even if I'm driving and you're going someplace new and you have to make a few
Mm.
turns, and then all of a sudden you're like, I wasn't listening for the past minute. Like, and you have to go back.
Yeah.
So,
Yep, that's the exact same idea right there. So that's kind of some of the stuff that I'm doing now, which was a carryover from some of my like smaller projects at Rutgers were actually looking at brain activity during exercise, post exercise. That was like kind of my smaller project work I got to do when I wasn't running controlled trials all the time.
so did you do anything where? Because when I asked about the subjects being able to see their own brainwaves and stuff,
Oh yeah.
the whole neural feedback thing, that's kind of popular. Did you do anything where people would be aware of their own, and learn how to, yeah, know what's going on in your brain better by seeing the visualization of the activity?
So So I know about it. I don't really do that specifically because that's more looking at oscillatory. So the brain activity stuff I do with event related potentials, most of that is once they're done, I have to like process data after the recording's over. I actually have to go in and run filters and algorithms and split
So it
up
doesn't look like
data. So
much.
all of it's post processing. Yeah. So for them, they would never know. I can see it just because I've got thousands of hours staring at EEG signals, right? But if you were to just show it to someone who's never seen it before, they'd be like, "What are you looking at?
Right.
You crazy person!" So it's like hieroglyphics, in code, and it's like, what the heck? Um, but if you were to do more of the oscillatory activity, and there's some cool visualizations now with EEG especially, where you can actually have on the screen the frequency bands in various colors, and you can actually look at the dominance of various bands. And so that would be something that a lot of researchers will use with like the neuro or biofeedback.
Mm-hmm.
We've done some like false biofeedback and some false stuff where we like manipulate stress levels. So like we'll induce stress by we'll tell them like, hey, you're going to get paid today, but it really depends on your performance. You have to get an 80%. So on the screen, we'll show that they're under 80% consistently because it doesn't tell them if it's right or wrong. And but then it shows their percentage go up or down.
Mm.
And they're like, I'm doing this right. I know him. I'm like, no, you're at 75%. You need to pick it up for the last trial here. And so like we've done some manipulations like that. We've done some false heart rate data just as a basic biofeedback thing where we showed them where their heart rate was like actually higher than what they really were. And we've actually showed them where it's lower than what they really were, and to look at how that maybe impacts their performance on certain things. Because if you show someone who's jogging that their heart rate's nearing max, they are likely going to get more tense and stressed out. And
Right.
then their heart rate will actually elevate. Whereas if you show someone, and they're going to probably underperform. Whereas if you show someone a lower heart rate, right, and even though it's higher at that time, they're going to feel more comfortable and relaxed. Like, oh, I got this. I feel fine. And so it's just one of those mental things that you can do with the biofeedback biosignals. But I am actually, one of my next projects for this next year, we're going to do, it's a pet project. It's just a fun one for me, but it's kind of a golf experiment. Golf is one of the few sports where you can actually measure activity while they're doing the
Right.
activity, like putting, especially because it's just not a lot of movement. That and like shooting sports is a big one where biofeedback and neurofeedback got really big because they're steady, right? And they were looking at the brains basically of professional shooters versus amateurs. And amateurs, brain activity actually spikes and goes way high, the beta band especially, because they're losing focus right before they fire. They get nervous, whereas pros, the brain,
Beta.
yeah, exactly, and they calm down and they get into a zone, and they're able to focus more. So I'm going to do that kind of with putting, and we're going to maybe do it with cyclists as well because there's a component with cyclists, and I can keep their heads pretty still where I can look at that feedback, and we can talk about like then implement that in a training program, which would be really cool. Is if they
Okay, so
know,
head movement is a
yeah,
determining factor there. Okay.
it's a major pitfall to EEG, but there's new equipment which is crazy expensive, like 100K plus for one unit,
Mm.
for research grade, I suppose. And there's nothing really commercially available right now that you could really do this with, but it is really good at filtering movement live, like while it's being recorded.
Mm-hmm.
Because it's really hard to do after the fact. Because when you're trying to filter out movement activity or movement artifact, is what we call it, it becomes very difficult because you don't know what was going on. Like you're not live in the moment watching the activities to see what's causing it. So you can't say whether it was muscle activity in the jaw or, them just moving their eyes too much. We don't know what it would be. So it's really hard after the fact to do it. But if you could do it live, like these new systems do, that saves you a lot of time later on because you're not having to re-filter out your data later on.
Right. Yeah, that's one time I did a calorimetry experiment with I think it was Hoffman. Do you remember him
Yep.
from? He was the chair of the nutrition department when I started, and then the other guy with the glasses took over, like little glasses, and I forget his name. I think he worked in B. No, no, he worked in B vitamins, like single carbon metabolism.
I can't remember his name.
Anyway, yeah, Hoffman was doing this thing, and I was super interested in it. He was working with this guy, Richard Wrangham, and they were just doing a simple pilot experiment to see if the metabolic stuff was different between eating the same plate of meat, whether it's cooked or raw. But the reason why I brought it up is I was sitting there taking this indirect calorimetry data on a Saturday, and we couldn't talk to the subject because it would mess up their like oxygen consumption. It would alter their oxygen consumption and CO2 production if you kind of got them doing too much. But then she was like falling asleep. So it was this really weird zone because you're sitting there, you eat a plate of food, and then you're just supposed to sit still for like a half an hour, which doesn't sound like a lot, but it's like, it's like a Saturday morning, and she's just there to get paid whatever amount of money for showing up for the study, and it's just a room, it's quiet, and you're sitting back,
Right.
and you're not like allowed to move, at least not significantly. So yeah, it's a weird zone because like we couldn't keep her awake like intentionally, but then she would
Right.
sort of start to doze off, and we'd have to like tap because she had the
The
calorimetry.
dome.
Yeah, the dome.
Yeah.
So it's like a deep sea diver type thing. You kind of.
Yeah.
I didn't like that. It felt.
Well,
Yeah, it was very kind of weird. But I guess what you're doing is more. They're probably not going to fall asleep, unless, except in that first study, the meditation stuff. But yeah, if they're doing something.
yeah. Well, you'd be surprised. I mean, people fall asleep all the time doing like when they're
Right.
supposed to be like pedaling. We'll notice the bike will turn off. I'm like, what happened? I'm like, they fell asleep. They fell asleep. They were exercising. That's so weird. We actually did a sleep deprivation study a couple years back where we had students purposely come in sleep deprived, and then we had them either watch a movie, and we had them do a cognitive test before and after. So they did one right before, like right when they got to lab. Then they either watched a movie or just like kind of hung out, and then took another test, or they did the baseline, then they exercised at low intensity, and then they took the test again. And you could probably guess the results. The person who exercised was more likely to perform better on that test, and their brain activity was more in the what we'd call arousal level or activated level, whereas the other group was basically falling asleep during their experiment. But the whole
Mm.
idea behind it was the concept of if you pull an all-nighter studying, right? What's best for you to get through your day if you have to go to work or if you got to go take an exam. Obviously, probably take the exam, because if you just studied all night, you should probably go take your exam. But it would be to go for some slight intensity, just walking or jogging to wake up to get your body going. Otherwise, you're probably going to suffer during that exam. So it was kind of a neat, just kind of one-off sleep deprivation study because I have a vested interest in that because my sleep was not great in graduate school. So I always wondered
Mm.
what would be best Is it better that I'm actually out? I would go play frisbee golf actually at the Rutgers campus on that campus. I would go out and just do a couple holes just to get outside and wake up. I was like, I'm falling asleep sitting here typing right now. I need to like go do something.
Yeah. Yeah. All right. Um, how about the heart variability stuff? I feel like that's probably an interesting topic, like a health topic in general. I remember you were doing the, because when we would teach the ECG, and
Hmm.
you were looking at my trace for a little while, and then some of the other teachers, and you said like, oh, good heart rate variability, and
Yeah.
I couldn't really interpret it in real time, but I actually went. I had a doctor's appointment not that long ago because, and I don't know how normal this is, but like once a week or something. I don't really notice it always consciously, but my heart will just skip a beat. Like it will just.
Is it a PVC? Did they call it a
I
PVC?
think so. Uh,
Premature ventricular contraction?
or no, it'll just go through a cycle of electrical activity with no, or I guess it's. See, now I already forget the the different Q, blah 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 blah.
Yeah.
But so I have, that's probably some not so great variability. That's not really what.
Well, it's very common, especially as you get older, to have. I think they're probably referring to a premature ventricular contraction, a PVC. I get them all the time now. It's the heart skip basically
Mm.
when you skip a beat. But if you hook up and watch yourself live, they make these cool devices. Actually, you can get them on Amazon for like 100, or not even 100. I think they're like $50 now. They're called oh gosh, what's it called? Tacky. I can't remember the name of it, but it's actually very. They're talked about a lot in medical circles. They're FDA approved, but you can actually use them and measure and watch on your phone your heart rate,
Mm.
and you can actually track your PVCs and make sure that they're not becoming more recurrent. And if they get to a certain point, it'll tell you like you should probably go to a doctor,
Mm-hmm.
right? And actually, you can send your data right to your doctor, which is really neat too. It's integrated into the a lot of the online systems, but it's very common to see those. I used to part of the calibration when I was in grad school, and even now, is I would hook myself up, and I knew that it would typically have one every like couple minutes, and so I would just sit there and watch it, and I would just make sure.
It
I was
would
like,
make
oh,
sure
there
it
it
picked
is.
it up.
Yeah, I was like, yeah, I got it's good. It picked up my PVC. So, but yeah, so it's I've gotten a little bit away from the HRV because it's really hard to, I guess, be an expert in kind of two different
Right.
systems. When I first got to grad school, one of our first experiments was actually or it wasn't even an experiment. It was really just a cross sectional study, but it was looking at. It's like a weird. I don't even know if you call it a theory. It's more of a model. It's like the idea that It's called neurovisceral integration, but it's looking at the mind-body interaction and how it impacts behavior. And so we would have people basically hooked up to HRV or to an ECG, and we would look at HRV in something called pre-ejection period.
Mm-hmm.
Um, and both of those are supposed to be synonymous with like your sympathetic and parasympathetic activity. So HRV is supposed to be your parasympathetic, and then your pre-ejection period is supposed to be kind of a measure of your sympathetic. And so you could then look at like, is someone more sympathetic or parasympathetically driven?
So
Okay, someone who's maybe
technically,
more,
for
yeah.
the designation of heart rate variability,
Hmm.
we're saying like, so if you have so many beats per minute that, and with a relatively stable period of all, assuming you're not like doing something that would alter that, it's actually considered normal and healthy for that to change, to vary a little bit.
Yeah, so heart rate variability in like the definition would be the variation from R to R
Right.
intervals. So the peak, the when you inhale, for example, your R to R's shrink really close. Your heart rate actually speeds up, and then as soon as you exhale, if you hold it, you go, your HRV spreads really far out. So it's these constant. It looks like this actually This is why I was able to detect it live. But you can look at slight variations, and once you see enough of the tracings, you can start to pick it up better. So people, for example, who are more fit with cardiovascular fitness, their HRV is through the roof. They inhale a little bit and you're like, woof, you see it shrink. And then they exhale, it's like, woof, and it gets really big. Someone who's maybe less in shape, the variation is a lot harder to see. They might inhale and it might just have a little change. And they exhale, little change. Okay. And the whole idea behind that is someone's ability to quickly adapt to something. So, I mean, it's maybe a microsecond, right? But let's say you're crossing the road and you didn't look, and then all of a sudden there's a bus coming or a car. It's your ability for your heart to very quickly make that change and woof, like change your mind, like, whoa, I need to step back. You know, it's just a split second, but in that little split second, you know, a lot of bad stuff can happen. So it's that, and then also the association of HRV with like heart disease and various other things. Because typically, if you have a lower HRV, you're going to have other complications that are going to be associated with that, like a sedentary lifestyle, for example. And there's a lot of bad things linked to that. So metabolic syndrome, like there's a lot of different things that HRV could be I don't want to say it's maybe a predictor of, but is associated with those.
And so it's sort of your respiratory activity communicating to your heart through your parasympathetic tone, almost as like a kind of yeah. So
that would be a good way to describe it.
Right. So if you're in that, so actually, if you were in a highly stressed, like sympathetic state, then you would also expect that to go down your heart rate variability, which you're already probably at a higher heart rate anyway.
Right.
Yeah. So you can't really compress the. You're already at a compressed heart interval.
Yeah, you're already at it.
Yeah, I've always noticed actually. I used to play a game when I don't know if they still have. I guess they still have these at drugstores and stuff, like a CVS. They have those sleeves you put your arm in, and it takes your blood pressure.
Oh yeah.
And usually they also take your heart rate. And I used to do this when I was like 10, you know, in middle school and stuff. My mom would be in one of those stores, and I'd get bored, and I would sit down and put my arm in the thing. And I didn't actually care about my blood pressure. I think at that age, I didn't know how to interpret those numbers. I just knew how to interpret the heart rate. And I would try to see how much I could slow it down. Because that's the only thing I could manipulate, really, that I could understand on the screen. And I could actually slow it down a lot by not exactly not breathing. Oh, did you just lose?
Hang on. Hey, can you hear me?
Yes.
Okay, hang on. Sorry, I got a weird. There we go. Okay, I can hear now. Sorry, I had to charge an iPod or an AirPod, and it like turned off all. So I got you now. Anyway, sorry. Keep going.
So yeah, so I would sit there, and I just noticed, you know, of course at the time I didn't know anything about heart rate variability. But I was able to, like, I would sit down and my heart rate would be 65 or something, and then I would let the machine go through its thing, and then I would try to slow down my breathing as much as possible, and I could lower it to like 35, you know, or like even lower. And I actually had once or twice I had friends come to try to do that. Like when we were, I was like, oh, check this out, and I was like kind of surprised. I don't know if they just didn't care, like they didn't think it was fun, so they didn't try as hard, or they just had garbage heart rate variability.
Yeah,
but they could.
Maybe your vagal tone was a lot better than theirs.
They couldn't slow it down as much. I mean, you know, when you're like 12 years old or whatever, it might just be that I was like, oh yeah, just try to like slow down your breathing, and they were like, yeah, I don't care, like I'm here for candy.
What was their baseline though?
That I do not remember any of these numbers. I just remember being able, like, thinking it was really interesting because you know, heart rate is not you know, cardiac muscle is not voluntary. So but it's kind of in this gray zone where you can intentionally manipulate your breathing rate, and you can, you know, do things like meditate that can, in a roundabout way, control your heart activity, not in a voluntarily, like not in the sense that you're in real time having it contract or not, but there is still some connection there.
Well, you know, I don't know if you wear like a smart band or anything like that, but Apple Watch has definitely kind of tapped into that world with their they have this breathing component that you can turn on or off, and it's based on your heart rate signal basically. And when it detects an anomaly, it will tell you to calm down and breathe. And the breathing signal is actually based on a resonance frequency of 6 breaths per minute, which is very common for most people to maximize their heart rate variability, which will then reduce your heart rate. So it's a very neat. I remember when I would drive home, like when I first moved to Texas, the traffic is a lot worse than I thought. It's like a concrete jungle down here sometimes. It's crazy, and they're really bad drivers. So it's not, at least New Jersey, there's some bad drivers, but it's like controlled chaos, and I kind of was okay with it. Here, it's just like, it's not good. Anyways, I remember oftentimes my watch would go off in the middle of driving, and it would be like, you need to take a breath. I'm like, you're right, I do. Like, I'm freaking out right now. So they have really like tapped into that, the whole idea, like they're taking some of these theories and ideas of like, something simple like the anecdote of like going to a CVS and slowing your heart rate down, just
Right.
breathing manipulation. And then they're like, hey, we should do this because it calms people down. I mean, that's the whole idea of taking deep breaths when you're upset, is to get you more relaxed and get you like recentered. So it's really neat how some of those companies are kind of like tapping in on those ideas, those childhood memories. I used to do the same thing, by the way, not necessarily at a pharmacy, but I used to take my own pulse, and I would, especially when I was like running or something, I would like to
Mm.
see how fast I could recover. Like
Um,
that was my thing, is I would like, even today when I hop on the metabolic carts and stuff, just to test them and calibrate them, I like to see how quickly I can recover from like a fitness test.
mm.
And it's really neat to see recovery rates in people who are more fit typically recover a lot faster. It just takes them 2 minutes to recover from like a 20-minute maximal effort. And then some people who are very sedentary, they exercise for 10 minutes and it was just a fast walk. It might take them 5 minutes to recover back
Mm.
to baseline. They might not even actually recover by the time they leave, right? They're still elevated compared to what they came in at, which is kind of crazy to think about that in terms of like health and what that means. Like they're never really recovering from activity, which is crazy. Whereas someone who's super fit, they recover instantly.
Yeah, they're not even close to baseline.
Yeah, I mean, well, they're close enough to where we can let them go.
Um, all right, so your research now is the um, I'm sorry, it's not the meditation stuff, it's not the heart rate variability stuff, it's the exercise and there's kind of attention things and the neural.
It's really looking at the effects of acute and chronic bouts of exercise on brain
Okay.
function, and it's across different populations. I like to say it's more just like, it's hard for me to describe sometimes because I'm more in a world of, I would say, psychophysiology, where I'm really taking the advanced neuroscience techniques that they use. So I went to like an NIH training camp with some of the world's best event related potential individuals, and I'm just really bringing in exercise and nutrition into that area. I'm not so much in exercise science bringing in their stuff. Like I'm more grounded in psychophys. Most of my conferences are psychophysiology related, behavioral type stuff, behavioral neuroscience type stuff. So that's really what my interest is in. And so then I can kind of bring in components of, like, I did a concussion study recently. I did one of those in grad school too, but I did another concussion study looking at like long-term concussions and
Were you the one that
a
did the
number of.
concussions on the rats with the?
I did not do the concussions on rats, but I gave a presentation on
Okay.
that because we were in the same, I think, seminar or something. But yeah, I gave a presentation on rats, how they would basically bore a hole through their skull and drop a weight
Yeah.
directly to the brain. They would like glue this stick that the cylinder would slide down and smack their brain and give them a concussion, and then they'd seal them back up. And then they compare them to like a sham surgery mouse and look at recovery rates, and then also looking at like omega 3s. That
Yeah.
was the big one for them, is they were
Was that
looking at
Sarah
omega 3
Campbell's?
fatty acids.
Uh,
Um,
because she did
she did a little.
omega 3.
Well, she mainly now, or at least when I was leaving, was getting into the gut
Right.
microbiome.
Right.
So I don't really know what she did with.
Okay.
She did a couple omega 3 things, and I know she had a couple physical activity omega 3 mice studies going,
Yeah.
but that was a long time ago. I don't remember if she published any of that.
Yeah. She was on my committee, and I remember at one point all the mice that I would sacrifice and take the tissues, she had me collect fecal pellets, which was usually pretty easy, but once in a while it was like this totally random thing where You open the mouse up and you go through the intestines, and the further down you go, the more well formed the like fecal pellets are. And once in a while, you just
Hmm.
have a mouse that like was in the middle of didn't have any well formed ones, and you're like the graduate students there with the tube, and you're like squeezing out like gushy feces. It's like getting all over the lid.
Didn't quite pell it out the way I wanted to.
And I actually that on a philosophical level that really bothered me because one of the things I really hate about microbiome science is I don't think they respect well enough the difference between higher up in the gut, like the microbiome is and should be like quite different, in like the species and the amount and stuff from like the top of this, say the top of the small intestine, or even midway through the small intestine to like midway through the colon. Um,
I wonder if they've looked at that in terms of like even just looking at something like the I would imagine, right? Because there's different
yeah.
bacteria in the upper portion versus the lower portion, so you would imagine there's got to be some effect downstream if you're getting mushy feces versus a well-formed pellet.
Yeah, yeah, yeah. Well, I mean, it's just the farther up they you go, like if you can't find any pellets lower down, you're just kind of stuck there. But yeah, I guess like a mouse could just be having a random like sort of diarrhea or something, or any kind of gut
Yeah,
irritation.
yeah.
But yeah, it because a lot of times when I look at microbiome stuff, they'll take fecal samples, and
Hmm.
which I guess is okay, but it's sort of like that's the end of the road. Whereas most gut problems are kind of associated with like closer to the stomach, so it's like as far away. And of course, the only other option is something invasive like a endoscopy. So I
Yeah.
could see why people would rather just take fecal samples, but it sort of doesn't. Like if somebody has something pathological at the tippy top of their small intestine, you might not see that in their fecal samples. Um, but anyway, that yeah, that concussion thing, that was like probably the most brutal, just because it's so obviously we kill rodents all the time, so that's the brutality is ever present. But there's something so controlled and like macabre about that. It's like a scientific bonker, like bonk machine
Yeah. Yeah.
designed to
Oop.
damage the brain specifically. There's something. Do you remember?
Well, and when they had the images, I would have liked to see if they had a video of it, but they had the images in pretty gory details. And geez, man, that's like very violent to just drop a weight directly on brain tissue. I mean, I get the point of it, but the severity, I don't think we would have the same severity. I mean, like some people would, very severe accidents, but maybe that was the point. I can't remember if that was the whole like, not treating the very, very severe TBIs, for example. I can't remember if that was part of the question. I sure hope that was part of the question they're trying to answer.
Well, with the rodents and stuff, you're always tempted to push the phenotype with the most extreme treatment possible, right? Because it's like the worst thing that can happen, and this, I guess, this is an insight into the science world, but like the worst thing that can happen is that you don't get results. You know, like if you
Right.
get the results you want, that's great. If you get actually almost the opposite, that can actually be great too. But if you just get
Yeah. Nothing.
yeah, so you're like, you're kind of incentivized, like, yeah, to hit the rat a little harder. Um,
Yeah. I've always been more of a no result is still a result type person because I would rather be someone who prevents a aspiring graduate student from conducting the same work I already did that
right.
I already showed no result in, right? What do they call it? The file drawer effect.
Hmm.
The number of papers that haven't been published and just get shoved in a file drawer because there were null effects. Like that's a little bit disheartening because you just wonder, could we have answered some questions earlier, or prevented some unnecessary studies from happening? Probably.
Oh yeah, definitely.
Um,
I
yeah.
yeah. When I said like as a scientist, I meant purely from the perspective of like the publishing bias and
Oh
yeah the
yeah,
way the
absolutely.
field
Because
is.
you're not going to get that published anyway, right?
Yeah, which is kind of that's one of those things where most people scientists would, if you were just talking to them, they kind of all agree that that's not good, and yet it just persists. It's like a really bizarre group effect. I guess I would not be. I would never expect for people to think null results are as interesting or sexy or worth, writing a Scientific American piece on or whatever as some
Hmm.
really important confirmatory thing about some effect or whatever phenomenon. But the kind of dry scientific analysis and just publishing for the record, I would think, should at least give, like on a philosophical level, they should all kind of agree, yeah, that is the same thing, but they don't. Or in practice, that's not what
Yeah.
happens.
I feel like a lot of that too contributes to the, the phenomenon of harking.
Of what?
Do you know what harking is? Harking,
Spelled?
Hark, hark.
No, I don't think so.
It's called hypothesis after results
Oh.
known. So I think it's a contributing factor to that, where people are no longer making, scientific inquiry or guesses prior to conducting the experiment. They develop a methods loosely based on something. They conduct it, they run their stats, and they go, okay, now I'm going to go write my intro,
Right.
um, so that it can get published, right? I just, to me, there are some, and I'm not going to name labs here, but there are some things I read and see, and especially in my world, a lot of people who are not trained in like the equipment that I know, like when I see something that's published from someone in my field and they're borrowing some of the techniques that I'm very well versed on, I go, nope. I was like, there's no way that's possible. I was like, because they didn't do it right. Their methods are wrong, first off. But when I see those things get published, it's just really disheartening, because I know there's no way they hypothesized that. Like, there's just no way it was so experimental, and to begin with, there's no backing evidence. So how did they ever even achieve a hypothesis? Like, so things like that are very frustrating when I read them, and I'm just like, okay, well, it's part of the publishing game, I suppose. Is I think some people are willing to remove the, what do you want to call it, the scientific integrity, just to get a publication, which I've never really been super interested in that. But
Yeah, yeah. I mean, and it is kind of, it's one of those things that there's always plausible deniability because
sure,
it's kind of like if you could somehow, like Babe Ruth with the like I'm gonna do the home run,
yeah,
like that, it's like with science, you don't have to tell everybody, this is the question I'm going to ask. You tell
right,
them after the fact in one paper all at the same time. Hey, this is this field, and maybe you've worked in it before, maybe not. This is the state of the field, and because of this, I'm going to ask this question. And that's you
hmm,
calling your shot. But you could call the shot after after you swing the bat.
yeah, and I don't want to say it's like not okay to question things, right? That's not the issue. It's more like when, let's just say, one lab, and you know the the denying is one thing, but when you have like a former student from that lab say, "Oh yeah, that's absolutely what happens," you go,
Right.
"Okay, well that confirms my belief." But aside from that, it's like when you see then these labs then acquire a big fund of money from data that's maybe not clean, and you go, "Interesting," so they're benefiting. Or you see that like the only citations in the next papers are their previous citations, right? And you go, "Wow." So this is really getting out of control now, because now we have this just full gobbledygook of nothingness and horrible, science, in my mind. And it's like, imagine how long now it's going to take to fix. Um, I'm not going to say I'm on a crusade, but I oftentimes will use those papers. I will blank out the names and do stuff like
Hmm.
that just so that people will know. But I will then show like a counter paper, and I go, which one do you think was like better quality?
Hmm.
Based on only like intro methods, blah, blah, blah. And just having people critically evaluate and try to get to the point of like, see how this one paper cites everyone in the literature and this paper only cites themselves. So it's like, that's a problem. And you notice how the one paper doesn't cite the other paper, but the other one cites that one? I was like, that's a problem. You're specifically leaving out things that counter you for whatever purpose it might be. But it's just it's like one of those things I wrestle with in terms of like when I'm doing my research and designing those things is yeah, I would like to answer a bunch of crazy questions, but a lot of them have never even, there's no foundation to them,
Right.
so I'm not going to just leap and just sell my career to try and do something crazy, you know. I want to build up a little bit of a base and kind of move it forward that way. And then also, I'm really big on replication, especially being semi tied to psychology. You know, psychology is notorious for having no replication
Hmm.
factor, whereas your biochemistry work, it's you know, it's very hard to, you know, things can, you can replicate, I think, as long as you're writing your methodology out properly and using the same stuff. I think it's a little easier to replicate that versus human subjects, you know, that type of work.
Yeah.
But I always try to build in a replication factor in most of my projects, just so that we have, and again, this kind of, I guess, alludes back to getting it published, but to have that replication factor and then an extension of that. So there's always a replication piece and then an extension piece, which is like, this is our addition to the
Mm.
literature. I think it's important to do that. Otherwise, if you don't have a little bit of replication from time to time or proof of concept at the beginning, then how do you know the rest of it is accurate?
Yeah, yeah. I've never worked with human, stuff, so I don't know. But I mean, it would be quite
It's a
scandalous
pain.
if a biochemistry like experiment was not replicable. I mean, that would be. And it's funny that different fields, like, it's actually not a scandal in a lot of areas of psychology if something's not replicable almost ever.
Yeah.
But yeah, and then in some things like protein biochemistry, it's a pretty big. I mean, there are, especially in molecular biology, there's this phrase called "in our hands," which has to do with, like, okay, we grew this blah blah blah, or we measured this gene, or whatever we did, and
Hmm.
there does seem to be a weird factor where sometimes things just don't work in some labs, and even that phrase, like, doesn't work. It's a very it's kind of insufficient to explain, like, how is it possible that you have, like, the same kinds of mice and, whatever, the same kinds of diet, and or say you give them a drug or something and it gives mice like colon cancer, and that's replicable, and you
Hmm.
do it in your lab for 20 years, and then somebody copies your methods and uses the same strain of mice and the same agent, and, like, doesn't, produce cancer or something. That's something I just made up. That's probably never actually failed to replicate, but
Yeah.
but there is
That'd be pretty
there is that
serious.
phrase, like, in our hands. This protein behaves this way. So that's kind of like the bench scientist version of admitting that replicability isn't perfect, but it's still pretty good usually.
Yeah, my I get lectured by my sister. She's an organic chemist, so she likes to pick on me for
Ah,
uh,
even more.
for replication. Yes, for very specific replication. She's like, "You know what happened if I couldn't replicate that?"
Yeah,
Sorry,
or, well,
sorry.
organic chemistry. I mean, that's even one step past biochemistry. I mean, if
Yeah,
your stuff isn't, I don't know, whatever, doing whatever, eluding at the exact same time as before, then it's like something's wrong.
yeah. Well, and a lot of it builds up on itself, so it's like they're creating all these, you know, various compounds and things, and you can usually pretty early on figure out if it's working or
Right.
not. You know, it's like you know, your end product. I mean, you can also look at the end product, but usually they're like early on, they're like, oh yeah, it's wrong, start over. It's like a recipe almost, you know, like and not only understanding those things, but then being able to follow recipes properly is kind of how I view replication. It's like, were you able to follow that recipe properly? And I guess even sometimes when you cook, though, you know, sometimes people get different results. So,
Yeah, yeah. I did organic chemistry in a lab before graduate school. I worked in a commercial lab, and
oh wow.
I was like, they were making, like, plastics and stuff. There were two sides to the factory. One made plastics for, like, I don't know, like say, like wheels on a skateboard or something, and then the
Hmm.
other division or part of the building was foam, and they were kind of two different types of things. And they would just bring me paint cans of chemicals because they would have a huge vat and let some reaction happen, and then they would at the bottom, like, tap it, like a keg or something, and fill up a paint can
Yeah.
and bring it to me, and I would apply whatever chemicals to it, and it had to have a certain value of this and that for them to do the next thing. And yeah, once in a
Hmm.
while they'd, add the same stuff together and let it churn for the same amount of time, and it just wouldn't, and everybody'd be like, what the heck's going on? And mutually recriminate each other. It's like, you
Yeah,
added the
his
thing
fault.
wrong. You tested, it's my fault because I gave them a result they didn't want. Because yeah, at that point, it's
Right.
like it is. You do it every day. They make almost the same thing every day on a schedule, so it's like pretty wacky when things don't work the exact same way. I don't know. Maybe it was just humid that day or something.
Well, it's really amazing how things can be so standardized like that situation in a lot of those situations, yet things can still go wrong and you can't get that replication. And then you talk about like, all right, now let's apply some psych theory in a group of, free roaming humans and see what
Right.
happens. And then people wonder why you can't replicate it. I'm like, well, it's because you have so many variables that you cannot control for. It's just, even when you control for pretty much every variable, you still get things that can't be fully replicated. Maybe they're replicated 99.9% of the time, but you're still going to get that one off where something doesn't replicate. So it's very interesting. I like those. I like those types of stories where everything's supposed to work out and it didn't. You're like, wow, that's so strange.
Yeah. So with the field, is there any like overall
Mm-hmm.
kind of, I don't know, perspectives that you have about the whole exercise? So you call your field neuro
I would say
or adaptive
so. A
psych
lot of
or
times, like if I'm well, I would say like behavioral neuroscience, and the behavior I do is
okay.
exercise, or some people prefer sport and exercise psychophysiology. I just think it's a mouthful. I think what I specifically do is a subset of behavioral neuroscience in my own mind. That's most of the journals I publish in is just neuroscience, behavioral neuroscience journals. So I feel like that's kind of more the realm that I'm in right
Do you get
now.
a lot of crap for
Uh,
being like a nutritional science PhD?
I did when I got hired. They were very much wondering why a person with a nutrition PhD is trying to apply for a kinesiology program. And I said, well, hey, if you paid attention and looked at my CV, you would see that all my publications are in kinesiology
Yeah.
and behavioral science, basically. So, plus, I have the education to where I can teach the nutrition courses, which they needed. So it was like even though they questioned it in the end, it ended up turning out to where I was an asset. Like I'm teaching a nutrition class right now.
Nice.
So it's paying off for them. It's helping them out quite a bit, and it was nice because then I can get out. I can get outside of the kinesiology world for a while too. It's just I get overloaded with some of the I call it bro science or junk science. There's a lot of it in exercise sciences, but in nutrition too. I mean, just there's just so much garbage out there. It's hard to filter through it all sometimes, and I like to escape and get to like a different realm for a while with nutrition.
That reminds me of our friends. There was a professor back at Rutgers. It was like the broiest of the bro science. Like,
Yeah, he's a chair at one of the biggest programs in the nation.
wait, is he still at Rutgers?
No,
Okay. Oh, so did he get like a promotion, like a go somewhere else for a? Okay.
massive promotion to like the number one program in the U.S. It's yeah, it's
Wow, he's
interesting.
really pushing it out there.
Really, yeah, that's probably part of my, when I was talking about certain labs finding just certain things that no one else
Hmm.
finds. Sometimes it's a little bit disheartening as an independent researcher that has a lab with, not tons of resources trying to like fight a good fight. And then you see situations like that. And you're like, cool, maybe I'm doing this wrong.
Well, who's
Maybe I
using
need
that?
to,
Who's using the
yeah.
gym now? Back at the the new science building.
I was quite a facility that they bought for that. So I don't really
Because he's the
know.
only person I ever saw in there.
Yeah, I mean, they ran it like I mean, it was almost like a little for-profit lab in a way because they charge monthly rates for many people to go
Oh,
there and use the facility.
oh,
So it was a way to feed into the research, right?
okay.
Yeah. So it was a very interesting little for-profit donated lab space.
Yeah, um, yeah, that's yeah, fun time. Yeah, I think I'm gonna have the same problem as you. Whatever I do next, because my degree says nutritional science. My the first six or so of my publications are mostly in endocrinology journals, or like a couple nutrition journals and a few endocrinology journals, and then since the postdoc, it's protein biochemistry. So If somebody looks at if somebody doesn't look closely at my CV, they won't understand. And if somebody does look closely at my CV, they also will not understand.
Yeah. Damned if you do, damned if
Yeah.
you don't. I would just make it very clear in your cover letter. I've been the chair of a couple search committees now, so I'm on the other end
Oh,
of it, and
good,
I
good.
kind of know what an application packet looks like. And I always read their letter of intent first because I want to make sure that I give their CV a fair judgment. Like, because I can see stuff in the CV, and I'm like, I'll look at journals and a little bit impact factors, but really I'm looking at like what type of work are they doing in general, and then if they come to our university, does it align with what they did in the past, or are they trying to transition into something new, or maybe they published something 5 years ago that they really love to do, they weren't able to do
Mm-hmm.
it, and then it's like, is that what you're trying to get back to? So as long as you write that in your letter, like, and as long as the committee's doing their job and reviewing materials like they're supposed to, you should be fine. But make it overtly clear, make it very clear to them that this is like what I want to do when I'm there, and this is how my nutrition PhD will benefit
Mm-hmm.
you. You might even put, because you were on the what they call it, basic
Yeah.
side. Yeah, you might even put something like because the basic side was more biochem
Yeah.
physiology. You might want to make that very specific as well. That you came from basic, bench science lab research, animal work,
Mm-hmm.
and you weren't on the applied side. Because if you see nutrition, a lot of nutrition programs are pumping out, RDs and
Yeah.
applied people.
Yeah.
And so you could have very quickly have like this thing in your mind where it's like, oh, they're just, they're looking at fry cut size and seeing, whether people, I don't know if you remember that one, but,
Yeah.
or they're looking at where they place water in a soft drink thing. And is it going to affect how much water someone
Yeah. Whether or
drinks?
not to tax the big gulp.
Yeah, yeah. Tax the big goal. Or, if you put a hamburger versus a hot dog on a sign for a barbecue, like who's going to show up? It's just like stuff that I don't even care about. But you don't want that in their head. When they see nutrition PhD, I would just they'll look at the CV, see the publications, but then that cover letter is going to be real big just to show your intent.
Yeah. 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 Because I guess when I apply, it'll either be for something continuing the biochemistry stuff or something going back to a more, whether it's animal models or just whatever. So yeah, I would just I guess I'll just have to write, have like a couple paragraphs that are unique to each one of those. um,
Yeah, and then same with your interview. A lot of times it'll be an intriguing prospect, and if you can get the phone interview, which is great, that's like one of the first things you got to bring up is they might not explicitly ask because they have to agree on a set list of
mm-hmm.
questions typically. And questions might not be, we noticed your degree is this, how come you're doing this?
Right.
You might have to work it into the conversation, right?
Yeah, I almost actually changed departments, like in the middle of grad school, because like I said, I was always hanging out with the endocrinology department because that's where my lab was in. And as I started to think a little bit about postgraduate stuff, I was like, man, endocrinology sounds so much more scientific than nutrition.
It does. Does. Yeah, I mean, even kinesiology, that's why, like, you keep calling it exercise science. I call it kinesiology. It's because I have a thing in my head where I'm like, kinesiology sounds more sciencey.
Yeah. Oh, I think exercise. Okay. Yeah. I guess to me, exercise science, because I saw what those people were doing, seems scientific. However, I bet there's a big like stigma of the bro science.
Yes. Um, yeah, it's really big stigma. And so that's why I push myself away from it, honestly, is I don't even really publish in a lot of kinesiology journals unless they're the like medicine and science and sports and exercise. Like it has to say science, and it's got to be more science based, even more lab, bench work type stuff. It just there's a lot of to me, when you publish in the same area over and over and over again, you're just preaching to the choir,
Mm-hmm.
right? No one's really learning anything new outside of your field. So that's why I like to branch out into these other journals, because it's like some of these people don't understand some of the benefits for the brain that exercise provides, and you can kind of reach a larger audience, which I think is great. And plus, I can remove myself from the bro science group, so it's even better.
Better conversation at the conferences.
Yeah, I can't have another conversation about protein powders, man. Like I just good. I've sat through too many talks and symposiums and dinners, where I can't do that stuff anymore. So I would rather talk to people who are, something I'm interested in, and also like they're interested in my work. And I just think it's a lot more valuable type of experiences and networking versus going to some of the conferences I've been to in the past where it is very cool. What supplement you doing? Cool. Which one you doing? Like,
Yeah.
horrible.
Yeah. What you bench? Um,
Yeah.
Speaking of that, do you like do any kind of specific diet or exercise regimen? Uh, and like, if so, is that at all influenced by being a scientist, or because most scientists are basically just, I guess you could say, just kind of like eggheads that aren't. I guess it's really hard to. So where I am now, where people are just doing like molecular and biochemistry, there's not a lot of overlap with people that care about their health or have that kind of a drive for things. It's just their work is extremely divorced from, you know, their lifestyle. Although I guess they might read stuff and feel like they understand it better because they went through some type of training. But whereas in the nutritional science department, there were kind of people that were interested in that stuff, but I feel like even still, there weren't a lot of people that were like uh, thinking that what they were doing and what they were learning and how to like interpret science, say the science around a supplement or something, or the science around like a type of protein powder, would be
Mhm.
something they would integrate into their life.
Yeah, no, I think that was one of the things I learned from the nutrition program is that most people didn't really care about that stuff. It was really like, where was the funding coming
Mm.
from? And a lot of nutrition research is actually like that. I've collaborated down here on a couple projects where, a lot of it is private contracts. They're not even grants, they're just contracts where they contract out the university and labs specifically to run testing for their white papers. They're the white papers that they publish on their site, but don't
Uh,
get published. So I've
like
been involved in
supplement
a couple of
companies
those
and stuff.
projects. Yeah, and it's just so weird because you can't talk about the data, you can't talk about the product, you can't publish the data, you can't even decipher like it, whether it's like you can't run the analysis. They don't even let you half the time, or they contract you to run the analysis, but you have to zoop, and they only show the data that they want to show because they're selling a product, right?
Hmm.
So I that stuff is always really just not super interesting to me because you just can't even tell people the truth, right?
Right.
Like, cool, it had one effect on one little enzyme that like it's not a magical cure for anything.
Right.
Like,
Right.
yeah,
Right.
no, it also gives you diarrhea, but they didn't tell you that, So, um, but it ups this one enzyme. Um, so I think I learned that at Rutgers too. Is like a lot of people, some of them are, there are some professors there who obviously really are interested in helping people, want to help cure things and do things like that, but then maybe didn't implement that to their own personal life. I think that's very common to study things and then be a hypocrite about what you study,
Hmm.
right? Like that's kind of me. I don't exercise like a very regular basis. I do watch my diet pretty good. My exercise as I've gotten older is less and less structured and more based around activity. So, like, I love to golf, for example. And it doesn't sound like an overly intense exercise, but it can be if you want it to be,
Hmm.
right? You can do about anything and make it more intense and exercise to get better at a sport. And that's kind of what I do is most of my activity comes from that type of sport, or I do activities like frisbee golf and, I trained for a couple half marathons a few years back just to do different things. I can't just go to the gym and do structured exercise. It's just that's never been the way that I operate. So that's one thing. So I am a bit hypocritical in that sense. But as far as the nutrition goes, you asked about diets. I have tried a lot of just funky
Yeah.
diets just to try them. And the problem is because I am a bit of an egghead, like you said, I do get fully involved in it. Like I get really heavily invested in it, and I learn way too much stuff about it. Um, and then that ultimately leads to spending too much money on it, right? So like
Oh
like
yeah.
we did keto diet, but we went hardcore keto, like not like joking keto where you like kind of tinker with
Yeah.
it. Like we went full on testing ketone bodies and measuring urine. Like
Nice.
I was like fully invested into it. Yeah, and I mean it was interesting. I'll just put it that way. I did feel way different. I was doing so I have access to a DEXA scanner. You know
Yeah. Yeah. Yeah.
DEXAs. for body composition.
Damn,
And
I
then,
wish I had access to
so I was doing a DEXA while we did it, and I was clearly losing a lot of adiposity, but whether it was specifically because of ketosis, I don't know. Like there's just a lot of things you can't answer with it, but it was cool to just try it
that.
and just to see what it was all about. I did feel pretty good. I was also doing I was doing anywhere from 12 to 18 hour intermittent fasting as well on top of the keto. So it was like an extreme
So you're
level
doing,
of,
and how many years ago was that?
that would have been 2 years
Okay.
ago now. Yeah, about 2 years. So it's just so different though. And it's really hard when you go out and do stuff. It's like not a sustainable diet to me personally. If you want to like have a social life or do things outside of it, because it's like, it just changes every decision you make about food. It's just totally bizarre.
Oh yeah, I know
We
about
had
that.
to, yeah, like I got engaged, for example, when we were doing this, and we were going to go celebrate and have like a dessert. And I'm like, what dessert can we have that's keto friendly? We're just sitting there, and like, I think we had like a couple strawberries and a few things. And it was just like, it was so sweet because we hadn't had sugar in such a long
Hmm.
time that was just like my taste buds had changed. And just, it was just having to make decisions like that, just long term, just was not a sustainable thing for us, even though it felt pretty good. And I felt like there was some decent results happening. It's just like, it wasn't realistic for us, and I think that's it's fun to try things. I think that's part of the researcher or scientist in me is I like to try stuff and just experiment with stuff.
Yeah, well, it's good that you kept track of it. I've been on like a pretty strong anti keto uh, crusade.
I don't blame you. It's not for everyone.
Well, I guess
It can
my
be
my
brutal.
crusade is just against the concept that like carbs or sugar are bad for you inherently, and that
Yeah, no,
yeah.
yeah,
But I do what I always tell people. Sort of like I really don't tell people like what to eat. I don't feel comfortable doing that because I actually did that for a long time, even before being a scientist. When I was just obsessed with like, this, for this 5 years I'm vegetarian or vegan or something. Um,
right.
but what I like to tell people is to keep track of like something. If they have access to a lot of stuff, like if they had a DEXA and if they could keep track of like their body temperature changes and like heart rate and all kinds of stuff like postprandial blah blah
Yep.
blah, that would be awesome. But even just how they're feeling, because I feel like when you see people online that get into extreme diets, they often like get to a point of diminishing returns and start to feel really crappy, and then they just do it harder. And
Hmm.
if you had, it's kind of like if you're lifting weights, like if whatever your routine is, you're not improving your numbers over like a year. If you're keeping track of that, you can see it and address it. Whereas if you're not, you just kind of get into
Right.
this like stuck in this rut, and you get like mad at people when they say, like if you're out and you can't eat anything because you're on some restrictive diet, and somebody is like, why do you even do that? And you get mad at them. Um,
Yeah.
but you should sort of be asking yourself why you're doing it, in a rigorous
Yeah.
way.
Yeah, no, I agree. And I think when we set off on that, it wasn't even sugar carb bad. It was just to see, it was kind of like one of those things. I was like, you want to try it? Like, we need to mix up our diet. I almost felt like your description of exercise was how I was with my diet at that time. I
Mm,
was like, I'm tired of like what we've been doing, and we meal prep. So all the meals are cooked on Sunday for the week,
mm.
and which is good, I think, for portion control. And that's what I meant by like, I kind of watch my diet now. But at that time, it was just kind of like, I was so tired of like what we were doing. I was like, let's mix it up and try something crazy for 3 months.
Yeah.
And so it was really just kind of an experimental thing, which I said it was very interesting, especially the first parts, I guess, when your body's transitioning into more like ketone body usage. And you do, if you've read up on it, like the ketone flu,
Mm-hmm.
the keto flu, it's a real thing. I was like flu-like for like several days when I felt like my body was transitioning. I just wanted to see what it was like, to see if there was any like, um, any worth or value to doing something like that. It was never kind of like what you said. I didn't really have anything against carbs and sugar. I love carbs and sugar. I love fat and salt too. So it was like it didn't really hurt me that much in terms of my in terms of the what I wanted to do or the goals I wanted to accomplish. I just wanted to monitor it and see what it did to my
Mm-hmm.
body, and that's why I think it's the inquiry, right? And I would note how I felt. I felt more alert and awake, and I was like, probably because I'm starving. Like there's a reason why I'm awake right now. I'm really alert. It's because I'm like freaking starving. I'm intermittent fasting and I'm on fats right now. So
Right.
my body thinks, you know, probably, probably my what is it called? My ancestral body right now is reverting back to like, you're in starvation mode. You should probably like
Yeah.
go
Look
find
for
some food.
food. Yeah.
Yeah.
Yeah. When
So,
I did keto, I did low carb for a long time, and then I was really strict for
mhm.
a short period of time, and that was the only time in my life when I could wake up easily in the morning. And I think it was because it like knocked my cortisol differently,
Yeah.
and I just had a difference because normally I have a very weak, at least like observationally, when I wake up in the morning, I feel groggy and I don't like I could sleep late every day. But the month
Hmm.
or so that I was really strict with the ketosis, I would just, my alarm would go off and I'd be like not even tired. And I was like, this is extremely different feeling. Yeah. I actually kind of, it seemed
I
like
don't know
not
if
that
that's a
healthy.
good or
Yeah.
bad thing. Yeah, because I felt very anxious actually many times when I would wake up randomly and I was like, I'm up. It's like 3 in the morning. I'm like, I'm up. And I was
Yeah.
like, what do I
That's,
gotta do? What do I gotta do? And it was just like I almost felt on edge when I was on that. And I have a friend who he's been on keto for 3 years, extremely strict,
mm,
like super strict. And he only eats once a day too. He's also just a once a day devourer. And he makes me anxious. Like I get by him. I don't believe in auras and energies, but I get by him. I'm like, I feel the anxiety. Like you're making me anxious. um, he's in crazy shape. He's in great shape. I mean, he can't argue with that.
mm-hmm.
But he's ripped out of his mind. He's like he's an athlete. He's very social, so you can't argue with those things. But he also doesn't sleep well, and he's anxious.
Mm-hmm.
And I'm just like, I don't know if I want that. For I don't know if the cost, the cost to benefit ratio is there for me. Like I'm
Yeah,
not,
I would even
I'm
be
not
more
sure.
worried that because I do think that a lot of people can get uh, they can lose a lot of fat and
Hmm.
have a certain kind of sustained energy for endurance exercise. But I do think that with that kind of a diet, especially when you're having those symptoms of the basically what would you think of like a cortisol thing, you're going to hit a wall eventually. It might not be until 10 years into it. But that's just
Yeah.
why I would recommend like keeping track of something that could let you know if you've turned some sort of bad corner. Uh,
Yeah, I mean, even just subjectively how you're feeling, like just a basic 1 to 10, I feel good or bad. And then if you have a smartwatch or some other something to track, you can look at basic things like baseline heart rate when you wake up.
mm-hmm.
And if it's at 90 when you wake up, that's probably not a good
Right.
thing. Like you're probably a bit stressed out, or something is going on in your autonomic nervous system that needs to be addressed. So yeah, it's very interesting. I think you're right. You do lose a lot of fat, but also I think some people who do that specifically to lose fat are oftentimes there's a lot, like they have a lot to lose anyway, right?
Right.
So it's kind of like someone who's extremely obese and sedentary, and you get them to walk 1 mile a day 3 times a week, and they lose 30
Mm-hmm.
pounds. You know, but then at some point, like you said, diminishing returns. Once they get to a point where it's like that walk is not going to do that anymore, well, guess what? You got to ramp it up.
Mm-hmm.
And I think sometimes people do it for the wrong reason, and then they see a little bit of benefit, and then it starts to kind of plateau, and then they go, "This isn't working. I'm going to switch out," and then they kind of revert back, and then it's that old conundrum you run into exercise science, right? Or at least in my field, is you exercise, you exercise, you exercise, you take a week off, you lost 3 weeks of exercise essentially, and it's kind of like you're starting back over.
Right.
It's kind of the same idea with nutrition to me. It's like you try, you get some gains, you're like, it's not working, let's switch it up. I'm gonna go back to a different way, and then you lose all those gains and you go crap.
Mm-hmm.
And sometimes even you over like it gets worse, right? Like it's even worse than when you started, and then it's just like an extremely frustrating experience.
Yeah. Well, yeah. I mean, the classic yo-yo thing, and that's another reason
Yep.
why the whole extreme, like what, yeah, like why would somebody? Because keto is sort of the version of like, like marathon training, maybe the
Hmm.
nutritional version. It's like you wouldn't really start somebody who's like, hey, I've never really exercised before. It's like, okay, hey, I've got the program for you. In 2 or 3 months, we're gonna have you on a marathon.
Yeah, it's just a 50-mile run. Don't worry about it. You've got three
Yeah, we'll
weeks
ramp
to get
up.
trained up. Body will be ready. Yeah, it can be pretty extreme in terms of that, and it can be a shock to a lot of people too. And I don't, like I said, I don't think it is for everyone. I almost think it's maybe more beneficial for people who are maybe have a little bit more steady diet and are able to, have a better understanding of how their body feels versus just a desire to lose weight. I don't know if that's always the best idea to like attempt a diet like that.
Yeah.
It's tough. It's brutal. It's like training. Like speaking of exercise, sorry you kind of brought this up. Were you trained to exercise when you were on keto? Like when you really were like into it? Because I'll tell you, for me personally, I was trying to run at that time. I couldn't run. I couldn't produce any energy. Like my body was not producing the power
Mm.
and like the endurance that I used to have. And I felt so tired. Like I would go a mile and I'm like, I'm done. I can't do anymore.
I was doing the MMA, like the jujitsu and stuff, and I I did low carb for a really long time, and then I did the keto. I didn't. The biggest difference that I noticed was I get migraines once in a while, but
Hmm.
when I would take my carbs below a ketosis threshold, if I would say go to the gym and do an hour of jujitsu and maybe an hour of something else, like work out pretty hard, uh, it would give me a migraine later that day that would last for like a whole day. Whereas if I would have that same thing and have a carb meal afterwards, I could recover without having to go through the the migraine. So that was my
Sure.
biggest thing.
Yeah.
But I do think that when I added carbs back after being low carb for so many years, I actually when I it was in grad school because I entered graduate school on a low carb diet where I was occasionally doing like a really low like keto thing, and I was eating mostly
Hmm.
raw meat. And
I remember
yeah,
that. That was one of the first things I saw you do. I didn't even know who you were, and I saw you with chopsticks, and you're eating what I thought was watermelon out of a container, and I was like, "That is raw meat. Those are meat cubes."
yes, yeah.
Yes, I remember
Um,
that.
so I added at some point because I started studying, nutrition at that level, and I started really questioning the precepts of, carbs are bad, and I just added them back, and I immediately gained a bunch of weight, but hardly any of it actually was fat. I think I was like rehydrating and like kind of more consistently having glycogen because I went from like 165 to like 175 in not very long, but my pants fit the same.
Hmm.
And then, because I remember, because I used to not weigh myself that much, and I was like over my cousin's house, and I weighed myself, and I was like had gained more than 10 pounds. And I was like, this is crazy. And then a few months later, I went to actually a jujitsu competition, and I had to weigh in, and I was 160 something. So I had lost. So when I added carbs back, I kind of had this big weight gain that wasn't really associated with a change in waist or anything. And
Yeah.
then it slowly pulled back. But I wasn't weighing myself on a regular basis, so I can't say how fast. But that was like one of the biggest changes that I noticed, and I think like pure force production, like kind of the weightlifting type performance, was some like the more long distance performance. Like slow burn type stuff. I felt pretty good when I was on a low carb thing, but the explosive
Hmm.
stuff improved when I added the carbs back.
Oh, definitely. I think that's a
Yeah.
yeah, it's kind of a given, right? When you're talking about what fuel source you're
Mm-hmm.
utilizing during those activities. So yeah, that's very very interesting. It's interesting to talk about the weight gain and stuff too. I've just been pretty steady since kind of the end of grad school till now. Even with the keto diet, I was actually maintaining, I guess, lean muscle mass or even building a little bit and losing kind of fat, which is the dream,
Mm-hmm.
right?
Yeah.
That is the dream. But it was kind of funny because I think it was like maybe right before that was when we had done our first half marathon. And I remember it being very odd when I was training for that. I was actually part of a study doing a training thing, and I actually put on like 6, 7 pounds training for that half marathon.
Mm.
And I was trying to figure out where it was coming from, but I could tell like stuff fit tighter and like it was like I definitely put on the weight somewhere.
Mm-hmm.
And I don't know if it was like the overcorrection for the calorie expenditure I was doing or what was happening. I just remember, and I know you're going to build some muscle, when you run a lot, like but typically those muscles aren't going to be, it's more like elongated, like,
Right,
slender
right, right.
muscles where you can, where you can
You're not
run,
bulking.
less power generating. Yeah, you're not bulking. Exactly. And I was just like, that's so odd to me, and for a long time I was taught, uh, especially in undergrad, how exercise was so important for losing weight. And I even got nailed in our comps for grad
Yeah.
school when you had to write a grant.
Yeah, yeah.
So one of my grant components was looking at exercise and fat loss. And instantly I just got hammered because obviously being in a nutrition program, they're like, "Are you stupid?" They're like, why wouldn't you do a nutrition intervention? Because that's way more proven, to have an effect on fat loss, especially than
Hmm.
exercise. And I was like, all right, you got me.
Yeah.
But it's still a thing being taught today. I even have students, because I teach mainly juniors and seniors now, who bring that same stuff to the table, talking about exercise for weight loss. I'm like, not really, man. I'm like, nah, no. I was like, it's just, if anything, a lot of times people overeat, and then when they stop exercising, they still have that
Hmm.
hunger, because you're so used to putting in those extra calories because you burn so many, and oftentimes we way overeat anyway, right? So then it just compounds the problem even more when you stop exercising. So it was like just like an interesting thing. It was like theory in motion when I was going through that training on how much weight I was gaining, and it wasn't a lot of muscle mass or anything. It was like just fat and like and things that I didn't want. And sure, I could run really far, but I was heavier, and it was just really weird to me. I was like, that's so weird, because I tried so long growing up to put on weight for football and sports, and I just could never do
Mm.
it. And then all of a sudden I start running and I'm packing on weight. I'm like, this is so strange to me.
Yeah, that's it. It could even be something like a stress response, and like even your body holding a little. I mean, it depends how many pounds you're talking, but a few pounds of water, I could imagine from just if you were doing sort of a more stressful, like a long distance running type thing on a regular basis, it might alter the retention, water retention.
Yeah, I thought about that too, but it was like, when I was doing my assessments and stuff, it was 7 pounds, and it did not appear to be water weight. I mean, we did
Hmm.
DEXAs, we did some of the really advanced bioimpedance that looks at like
Hmm.
hydration, and every time I would get my assessments, I had the same hydration levels, and I was just like, okay, this
Uh,
is interesting. I was
yeah.
like, I don't really get what's happening.
Well, I mean, your body does, it does need to fuel the long distance with something. So,
Yeah, yeah, and like I said, I think a lot of it was just like, especially when you don't exercise in a very structured basis, when you start to do like 10-mile runs on a Sunday, it's like you're going to eat a lot and drink a lot when you get back. Like your body, the first thing you want to do is you want to restore that energy. And then a lot of times you're just going to overshoot your mark. And I just had an issue with that. I could never find the right spot.
yeah, that 10 miles, that's not me. that's that's never been my
Yeah. I
cup of
mean,
tea.
I hate running, but I was doing it more as like as a companion with my, with my girlfriend at the
Mm.
time. So it was, we were doing that together and like basically pacing each other and doing the same training. And it was like it was 3 months of training. Starts really easy, but then you're running three to 4 days a week, and then Sundays were long runs, and you max out at 10 miles, and then you start to taper off right before the event, a couple weeks out before the event. And then, I mean, it's nice because it does prep your body for 13 miles, but it's still not fun. Like 10 miles sucks.
Yeah. Yeah, that's all right. Well, I have kept you for a pretty long time. It's been like 2 hours. So,
Nice. Well, it's good catching up.
yeah, this is kind of a weird, like a weird interview type talk because we actually for real haven't talked for like 5 years.
Yeah, I know, it's crazy how, like I said at the beginning, how fast like time can go, just like that. And it's like all of a sudden, like, where was grad school? Where's
Yeah,
this?
I also have talked to Dr. Merrill recently for the audience,
Oh,
the
nice.
our boss when we were teaching together, because I wanted him to write a letter for me, and he's one of those people that I'm sure if he likes you, like he will really do a good job because he takes everything he does seriously. Um,
Yeah, he wrote me a letter. So it was interesting. He had me write my own letter, and then he wrote a letter, and then he mashed the two together, which made a really nice letter.
Wow, that is interesting. I would not want to do that. I would not want to write my own letter. Um,
He, I did not like it. He said I was too much, which, whatever. I mean, that's, I guess, a compliment, but it is a very intimidating, especially coming from someone like Dr.
yeah.
Morrell. Sure, tell me about your accomplishments. Okay, I'm sorry.
Yeah. All right. Well, thank you for being on Kyle and Friends, and I'm gonna hit stop on the stream. Oh, do you have any kind of like, um, I don't know, like website or anything that you would want to people with the?
Um, Not really. I mean, you can just go to my UNT profile. I got my lab website on there. It's associated with the Applied Physiology Lab at UNT. I don't have my own independent website at the moment. I did, and I took it down. Maybe for the same reason that when you were talking, you were writing on yours.
Yeah.
But yeah, you go to the Applied Physiology Lab. There's a section in there with psychophysiology. It's not much to look at. They're redoing everything, so at some point it'll be re-upped and it'll have some cool photos of the research we do, the lab space, some of the equipment that we have access to, and then a couple of the published studies we have up.
Yeah, I'll throw a link. I'll just grab a link to it when this gets published and put it in the description.
Cool. Sounds good.
Alrighty, ending the stream now. Bye, everybody.
Bye.